All right, in factoring unit section 2, we're talking about here factoring with the GCF. Now, make sure you write this down because this will be crucial to your understanding of how to work this kind of problem out. Factoring the GCF is the opposite of using the distributive property. Now think about what I just said. Factoring the GCF is the opposite of using the distributive property. Now, if you recall, when we would use the distributive property, we would take A on the outside of the parentheses times the quantity B plus C, and what we would get is A times B plus A times C. Well, that's what we used to do with the distributive property. Now, in factoring this, I'm going to give you the answer, basically, and you're going to give me the problem. In other words, we're just working it backwards. Now, and keep in mind that factoring means to change the problem to multiplication. Factoring, we're changing to multiplication. Remember how we would factor a number and we'd come up with all the prime factors? Well, that's changing it to multiplication. We're going to take a polynomial, 24x plus 48y, and we're going to factor it. We're going to change this to a multiplication problem. Well, how do we do that? Well, basically it comes down to 3 steps. Factoring the GCF, again, make sure you get these steps written down in your notes also. Factoring the GCF. Number 1, find the GCF. Simple enough. Let's go back up here to number 1. 24 and 48. What's the GCF? Well, in the 24, does it go into 48? Yes, it does. So 24 is the greatest common factor. Is there an x in common in both of these terms? Right, no, there's not. Is there a y? No, there's not. So the GCF is in fact 24 for number 1. So we have that part. Number 2, actually divide it out of all the terms. So here's what we're going to do. We're going to take the 24x plus 48y, and we're going to divide them both by 24. Show this step. Now your answer will be the GCF 24 times whatever it is you have left over when you divide out the 24 out of both of those terms. So if you take 24x and divide it by 24, you have x left over. Bring down the plus sign, you take 48y and divide it by 24 and you get 2y. So your answer would be 24 times the quantity x plus 2y. This is how we changed it to multiplication. Now we have 24 times this parentheses, and that's called factoring. So you just factored your first polynomial. In number 2, find the GCF. Well, let's see now. Between the 9 and the 3, we have a 3 that's in common. Now, between the x squared and the x, smaller exponent, x. So take that GCF, the 3x. We're going to take it times. Now, 9 divided by 3 is 3. X squared divided by x is x. Bring down the minus sign. Class, make sure you understand that when 3x is divided by 3x, what do you get? Not 0, you get 1. Any number divided by itself is 1. In number 3, 45m to the third minus 15m squared. There is a 15 in common. Look at the m to the third and the m squared. What's the smaller exponent? Well, m squared. So 15m squared is your GCF. How do you factor it out? Well, you're going to write down your 15m squared, and then you're going to open up your parentheses and simply divide these two terms by 15m squared. So you're going to get 45 divided by 15 is 3. M to the third over m squared is m. Bring down your minus sign. Again, you have 15m squared over 15m squared. Any number divided by itself is 1. In number 40, 4, you have 30, 1, right? The coefficient here is 1, and negative 6. Well, it doesn't do any good to factor out just 1, so we're going to leave the coefficient alone. We have m squared, and no m's, so there's no m's in common in number 4. But look at the n's. We have an n squared, We have an n and we have another n. That means we have an n in common. Now it's important for you to understand, and let's write this down also. However many terms there are in the original problem, that's how many terms are going to be left over in the parentheses. However many terms you start with, that's how many you're going to have in your parentheses. So let's take a look at number 4. When we factor out the n, I get 30. I bring down the m. N squared over n is n, plus m squared, the n's cancel, minus 6, the n's cancel. So we have n times the quantity 30mn plus m squared minus 6. We have 3 terms to start with, and we have 3 terms in our parentheses. In number 5, what's the greatest common factor? Well, you got it, it's x. So divide all 3 terms by x. Write the GCF down, x, and it's going to be taking times x to the third minus 18x squared plus 22. Now, you've probably already figured this out, but what's a good way that you can check to see if you have the correct answer? That's right, you're going to be using the distributive property. If you can use the distributive property and come up with the original problem, more than likely you have that problem correct. In number 6, a little bit of a trick question here. 6n minus 7n in like terms, we're going to have 4m minus n, and that'll be your final answer. Number 7, 14, 42, and 49. What's the greatest common factor? And notice, class, that I'm going through these and just doing the coefficients first. So I'm going to have 7. And then I go through the alphabet in alphabetical order. And the only thing that I have here are all these c's. And again, I pick the smaller exponent, the smallest exponent in this case. So I'm going to have 7c to the third times the quantity. Now, when I divide this out, I take 14 divided by 7 and get 2. C to the third over c to the third cancels out. Minus 42 over 7 is 6. C to the fifth over c to the third is c squared. And then 49 over 7, so we'll have minus 7. C, closure parentheses. Number 8. With 10, 35, and 5, the greatest common factor would be, that's right, it's 5. X to the third, x squared and x squared. The smallest exponent, x squared. So write that down under all the parentheses, under all the terms. And then y squared, y to the fourth, and y. We're going to have y is the smallest exponent. So your answer is going to be 5 x squared y. And now we divide out all these terms. 10 divided by 5, 2. X to the third over x squared is x. Y squared over y is y. Notice I'm doing these one at a time. Small bites, take it a step at a time, you'll get to your answer. 35 over 5 is 7. The x squareds cancel. Y to the fourth over y is y to the third. And this 5x squared y over 5x squared y, well, they cancel. So do we just close the parentheses and leave it? No, go back to what we said a while ago. However many terms there are in your original problem, that's how many you need in the parentheses. So going back, I have 3 terms in my original problem. How do I get 3 terms in my answer? Well, keep in mind that whenever you take a number and divide it by itself, you get what? 1. So those are our 3 terms, 2xy minus 7y to the third plus 1. You go ahead and try 9 through 12 on your own if you haven't done those, or excuse me, 9 and 10 on your own, and we'll come back in just a second and see how you're doing. Hopefully you paused the video while you were working those problems out and got for number 9, 3ab squared is the greatest common factor, and that would leave you with 10ab minus 2a squared plus 1. And then in number 10, now look carefully at what your GCF here. Yes, 4 times 7 is 28, but there is no common factor between 4, 28, and 7. So it's just mn times the quantity, 4m plus 28n plus 7. All right, now going on to numbers 11 through 16. Here's another thing we need to keep in mind. Parentheses can be a factor, which means it could also be a greatest common factor. Think about this. Look at number 11. Isn't 2y plus 5 being taken times 5x? That makes the 2y plus 5 a factor. And isn't 2y plus 5 in this parentheses being taken times 9? Or in this case, I should say negative 9. So that means that 2y plus 5 is a common factor. So what do we do with that greatest common factor? We divide it out. So we're going to take 2y plus 5 and go ahead and put parentheses around the 2y plus 5. Keep the parentheses around there. And we're going to divide that out, just like we did above. And we're going to have 2y plus 5, whatever that parentheses is, bring it down. When this cancels, you're left with 5x. When this cancels, you're left with minus 9. And there is your final answer. In number 12, x plus 1 is a factor. And in this one, x plus 1 is a factor. That means the x plus 1s are the common factors. So when we divide it out, we get x plus 1 times the quantity. Now, when those cancel, we're left with 6. It's going to be a minus. When these cancel, we're going to be left with 2x. So x plus 1 times the quantity 6 minus 2x. In number 13, we have x plus 2 in parentheses here and x minus 3 in parentheses here. And keep in mind that it is the entire set of parentheses that is the factor here. So we really don't have anything in common here. This is x plus 2, this one's x minus 3. It's all or none. So what do we call a number that can't be factored? Prime. In number 14, we have 2x plus 1. That is a common factor. Keep the parentheses. Keep the parentheses. Bring that greatest common factor down, the 2x plus 1. Keep it in the parentheses. When these guys cancel, we're left with 4w. When these guys cancel, we're left with minus 7. So 2x plus 1 times the quantity 4w minus 7. In number 15, we have 4z minus 7. Here we have 4z minus 7. So factoring it out, we get 4z minus 7 times the quantity, 9 plus 3m. And last but not least, number 16, the one that we've been waiting for, the most important problem, the last one. We have an x plus 5 in common. Put it in parentheses. Now when we factor that out, we have x plus 5. Now when we factor these out and cancel them, what do we have left? 8y. Keep in mind that what we were talking about up here earlier, when we cancel these, what do we get? Right, plus 1. Well, good luck on your assignment. We will talk to you more in class. Have a good day.